Good evening, all, and welcome. Good evening, all, and welcome to this fourth session of Institution of Naval Architects for the year 2025. Today's session is a very important topic. Why indigenizing advanced welding is the need of the hour for Indian shipbuilding industry. This is presented by Dr. Krishna Prasad, engineer from Cochin Shipyard Limited, who's right there in the shipyard and at what we call as the pointed end of the actual shipbuilding activities. And to chair today's session is Professor Pankaj Biswas. It's my privilege to introduce Professor Pankaj Biswas. He is a professor at the Department of Mechanical Engineering, IIT Guwahati. He did his BE in Mechanical Engineering from IIEST Shipur and MTech and PhD from the Department of Ocean Engineering and Naval Architecture at IIT Kharagpur. His work spans different areas in manufacturing and design, such as shipbuilding, building technology, 3D printing, and forming by line heating, with an experience of around 17 years in these areas. His research areas are on computational build mechanics, similar and dissimilar friction stir welding of steel, hybrid welding technology, solid-state 3D printing, finite element analysis of weld-induced distortion and residual stresses, finite element analysis of additive manufacturing process, analysis of large welding structure, forming by line heating and modeling of welding processes using soft computation techniques. So it's very appropriate that he's chairing this session. Presently, he's working in the field of machining and tribology also. He has guided 4 IPDF and 1 NPDF, 14 PhD scholars, 47 MTech students, and 46 BTech students in the area of welding, line heating, and 3D printing. Currently, he is guiding 8 PhD students in the welding, additive manufacturing, and line heating areas. He has published 116 journal articles, 110 conference papers and proceedings, 25 book chapters, and 8 patents. Currently, he is guiding 1 IPDF, 1 is in welding and another one in machining area, 8 PhD students in welding, 3D printing, and line heating areas. He has developed 3 NPTEL courses, 70 hours of video lectures, and they are titled Fundamentals of Welding Science and Technology, Welding Application Technology, and Fundamentals of Thermomechanical and Fatigue Analysis of Weld Structures. The audience can also listen to it and get benefited. He has got different awards and honors. The IEI Young Engineers Award in 2013-14 in Mechanical Engineering discipline is one of them. He has worked in 11 sponsored and consultancy projects and is currently working in another 14 sponsored consultancy projects. With this introduction, sir, I hand over the session to Professor Pankaj.
Thank you so much for your consideration in this prestigious what is called society, that is Institution of Naval Architecture. Actually, especially I want to thank my friend, you can say, who is Dr. Manu Koirala, who was my friend in during the time of Indian Institute of Technology, Kharagpur. We both together actually did this, did the what is called PhD and MTech at IIT Kharagpur in the Department of Ocean Engineering and Naval Architecture. Thank you so much, Dr. Manu, for inviting me in this prestigious what is called society. So instead of spending time, I want to introduce what it's called the speaker first. After that, we will start the session. Okay, so first of all, it is my great pleasure to welcome you all to this what is called online technical session, which is the 4th session of this year 2025. The topic is on why indigenization advanced welding is the need of the honor of Indian shipbuilding industry. It is an online technical session which is given by Dr. Krishna Prasad S, who is the eminent engineer in the Cochin Shipbuilding Shipyard Limited. This session is you can say organized by what is called Institute of Naval Architecture. On behalf of the entire organizing committee, I, Professor Pankaj Biswas, extend a warm welcome to all the participants, distinguished guests, and the respected eminent speaker, that is Dr. Krishna Prasad S, Cochin Shipyard Limited. First of all, I want to introduce Dr. Krishna Prasad. Dr. Krishna Prasad is currently serving as a Senior Manager of Strategic and Advanced Solution at Cochin Shipyard Limited. He holds a bachelor degree in the mechanical engineering from TKM College of Engineering. He did his master's degree in welding engineering from National Institute of Technology, Tiruchirappalli, which is which is the best NIT you can say. And he did his PhD in welding engineering technology from Cochin University of Science and Technology. Dr. Krishna Prasad has over 12 years of experience in CSL. He is currently the project manager for the AUV project of NSTL, which is spreading the development of an indigenous automated production line, a member of the Autonomous Surface Vessel project of CSL, also leading the startup program of CSL. During his tenure in ship repair, he handled repair of more than 50 diverse ships, including warships, aircraft carrier, and offshore vessels. His expertise extends to developing innovative welding procedures and managing a strategic project. An active contributor to the research, he has authored 17 publications, including studies on automated welding techniques, hybrid laser arc welding in shipbuilding, and underwater welding. To all the participants, I encourage you to engage deeply with this content of this eminent speaker and eminent experienced speaker, you can say. Interact with this eminent speaker and approach this session with the dedication and discipline. Now, I would like to humbly request our esteemed invited speaker to kindly enlighten us with his insightful technical topics related to welding of India's shipbuilding industry. Now, I'd like to request Dr. Krishna Prasad to start his session. It is a 30-minute session. This you should keep it in mind. And after completion of session, there will be discussion if the participants or eminent guests have any what is called queries. He can ask question. Accordingly, we'll discuss and we'll take the what is called output from Dr. Krishna Prasad. Now, I'd like to request Dr. Krishna Prasad to start his session. Thank you, Dr. Krishna Prasad.
Good evening, sir. Thank you, Session Chair, Dr. Pankaj Biswas, respected Dr. Manu Kurula, Bharadwaj sir, and all the officials of the Institution of Naval Architects, India. Without further introduction, I think I will start with the presentation. I hope the slide is
clearly visible. Yeah.
Thank you, sir. Yeah. Firstly, I thank the organizers for inviting me to deliver this talk. It is absolutely it's a privilege and an honor to deliver the talk on why indigenizing advanced welding is the need of the hour for India's shipbuilding industry. The topic assumes importance presently, with the government aiming to rank India among the top 10 global shipbuilding hubs by 2030, and then subsequently to become the top 5 by 2045 under the maritime Amrit Kal vision of the government. So in this presentation, I would be going through the summary of the topic would be like a brief introduction on why welding is considered as the backbone of shipbuilding industry. What is the future trajectory of the Indian shipbuilding industry, and 2 case studies which highlights why indigenizing key technologies in welding is important for our journey to meet our ambitions, and finally concluding with the need to indigenize. Welding is the enabling technology for shipbuilding. The history of shipbuilding and welding is deeply interlinked, especially in the modern era where welding has become the backbone of all the manufacturing industries. All the modern ships, as we know, are designed to be all welded. There is a deep connection between welding and shipbuilding, and it actually started with the World War II, where there was a huge requirements for mass production, and welding was selected to meet the demands of the various countries, especially the US, to make numerous huge quantities of ships, and it revolutionized the ship construction. And the picture shown here is one of the Liberty ships, for which mass production was done using welding. And what welding contributed was that it led to standardization of manufacturing methods. It made codes which enabled to industrialize the welding. Major pivotal moments that transformed the welding industry, or that adopted the reason why industry adopted welding as the key manufacturing method, is one during the World War II era, where the one-sided submerged duct welding machine were introduced. It enabled the industries to do seamless long butt welding, and there was a program in the late 1970s called the National Shipbuilding Research Program, which actually changed the power supply technology, and it adopted the inverter power supply to the welding machine, which enabled man portable welding equipments. It increased the flexibility, it increased the the ease of using the welding machines by industries. And it is actually welding that contributed to industrialization of shipbuilding. And where are we actually heading to? As I told in the introduction, we have a huge ambition in our country. That is, by 2030, we are aiming to become the top 10 among the global shipbuilding hubs, and by 2045, we are aiming to become the top 5 shipbuilding countries in the world. Shipbuilding is a strategic industry for national growth. But things are not very promising, especially in the shipbuilding manufacturing side. There is a council called Technology Information Forecasting and Assessment Council under the Department of Science and Technology. They have published a report wherein they have identified shipbuilding and waterways as one of the slow-moving areas, slow-moving sectors. They have identified that the indigenization happening in the shipbuilding industry is very low, and the dependency on import technologies and import equipments in the production flow are very high, and it leads to low productivity and also affects the competitiveness of the Indian shipbuilding industry. If you take the Indian welding industry in totality, it's a very huge market out there. The market size is around $750 million US. The bulk of the size is contributed by the consumables, and almost 45% of the welding equipment, that is a machine, we are depending on foreign suppliers. In the Indian context, Indian Navy remains the main customer. That means they play a huge role in driving the demand of the Indian shipbuilding industry. Globally, the three countries, China, Japan, and Korea, contribute to 90% of the global commercial shipbuilding. And how could India catch up in the coming years? That's something we need to really think about. Generally, what we have seen is, what we have seen is, in Indian shipbuilding industry, we hugely depend on conventional welding techniques, and also at the same time, we also have an advantage, that is, we have affordable labor cost. So using conventional welding techniques to meet the production have been the choice of all the Indian shipyards till now, but it may not be adequate to meet the future requirements. So the only option that is left to the Indian shipbuilding industry is to tap the new technologies, and that too, in a very quick manner and with confidence. Generally, shipbuilding industry is considered as an industry where the decision making is generally slow. There is a huge resistance to bring changes. There is a huge resistance to bring changes in the production flow, which will affect the existing production line. But a time has come now to quickly adopt new technologies, to increase the efficiency of the production flows, to modify the existing production flows. Only then we can actually increase the productivity of our shipyards and compete with the other Asian and European shipbuilders. The two critical questions what the management of shipyards should really ask is, are the new investment targeting the future or the current bottlenecks, or are we utilizing the existing capacity fully? And are our existing capacities able to meet the present and future requirements? What I think is that with the existing technologies, even the current demand for shipbuilding in India will not be met. So there are a lot of developments happening around us, especially in the welding technology. There are new power sources being introduced, which gives high efficiency. There are digitally controlled systems being introduced by various OEMs, which enables very efficient modes of metal transfers. New welding processes are being introduced in various shipyards, actually, in the European side, namely hybrid laser arc welding. Friction stir welding has been in use in various shipyards to address welding of aluminum, or particularly soft materials. There are new NDT techniques that are being available: phased array, ultrasonic inspections, digital radiography. And one important thing, what all the naval architects are aware is the use of new materials, basically high strength, low thickness steels like DMR 249 alpha and other high strength alloys And it is in this area where we are having a very big problem with using conventional welding techniques. These conventional welding techniques are suitable for mass production, suitable for welding various ranges, various types of materials. But when you take high strength, low thickness materials, the inherited heat input of the conventional welding techniques gives lot of heat input, will give lot of distortions, which causes additional time for reworking, for addressing the distortion and things like that. So it is imperative that a new technology or a better technology replaces the conventional arc welding to address especially low to medium thick materials. So why is there a gap in adopting technology? So despite the global advancements, the hybrid laser arc welding or friction stir welding has been in use in various shipyards from early 2000s or late 1990s. But it has not really come to the Indian shipbuilding industry yet. So there is a huge technology gap which the Indian shipbuilding industry has to address. One of the basic reason is due to the lack of awareness, the lack of accessibility towards this technology, and most importantly, due to the affordability of these key technologies, especially hybrid laser arc welding, where the entire process has to be remodified, the entire process has to be fully automated to enable the process. So in the case study, what I have done is I have taken hybrid laser arc welding as one of the case study. For audiences who are not familiar with hybrid laser arc welding, I will give a small introduction. Hybrid laser arc welding is actually a type of arc welding itself. As the name suggests, it is a hybrid thing which combines the laser welding as well as an arc welding. Generally used arc welding process is the gas metal arc welding or MIG welding or MAC welding. So in this process, the heat energy from both the laser beam and the GMAW impinges on the same point. That means on the joint where you need to do the welding, both the laser beam and the arc beam get impinges and causes a combined heat. The bulk of the heat is generated by the laser beam. Say around 70% of the heat is contributed by the laser beam, and because of which the heat input is very focused, because the laser diameter is very small, in the range of 0.1 to 0.3 mm, and only around 20 to 30% of the heat is contributed by the conventional arc welding process or the MIG process, which basically acts as the filler. So here in like in laser welding, it causes a keyhole. That means the shape of that means the depth of the weld is very deep and it is not very wide. It's a very narrow keyhole that is formed, and the top will be filled with the GMAW. So more or less you can see the weld shape will be like a wine shape cup. Wine cup shape weldment is produced, unlike the welds produced in conventional arc welding, which is wider. So the main advantage of this process is it gives very high quality welds. The speed of welding is very high, and also the quality of the weld that is produced is very superior compared to the quality produced by conventional arc welding. So the benefits of hybrid laser arc welding are increased welding speeds, reduced filler usages. As I told, it gives deeper penetration. The seam quality is better. Since the heat input is very focused, naturally the thermal stresses are less, which causes reduced distortion. It's a fully automated process, so you need not depend much on the labor, so the labor cost can be reduced. And since it is a fully automated, you have better process control. So considering all these aspects, hybrid laser arc welding is actually a very preferred welding process to address low to medium thickness steel plate welding in shipyards. There are many shipyards who have who are currently using hybrid laser arc welding in the world. The main shipyard which introduced hybrid laser arc welding is Mayerwerft, Germany. They have a fully automated panel line with laser GMA welding, which can GMA hybrid laser arc welding, which can do butt welding and fillet joint or T joints up to 30 meter into 25 meter stiffened panels. And Turku, Finland, they also have a hybrid laser arc welding in their production flow since 2006. For Mayerwerft, Papenburg, Germany, they had implemented hybrid laser arc welding since early 2000s. And even before that, during 1990s, they had implemented laser welding, conventional laser welding in their production floor, and they made sandwich panels for ship deck constructions using using pure laser welding. And one of the bigger shipyards in the world, Fincantry, they are also presently using hybrid laser arc welding to address welding of plates between 6 to 15 mm thickness. Integrators like Pemamek, Castellini, they have been supporting Fincantry to implement the hybrid laser arc welding in their production flow. STS France, they have already implemented hybrid laser arc welding in their production flow. It was integrated by a company called Pemamek. Again, it's a Finnish-based welding integrator. In-class shipbuilding of the US, they have also implemented hybrid laser arc welding in their production flow. And we know that that is also implemented by Pemamek. And Protets of the Norway, they have a hybrid laser arc welding setup of 16 kW capacity. And it's been in operation since 2019. Mitsubishi Heavy Industry, as we know, they had hybrid laser arc welding in between 2009 and 2012. No available information is there to confirm whether they are presently using hybrid laser arc welding, but from the market study we have conducted, they have been using hybrid laser arc welding during 2009 and 2012. And Hanwha Ocean of South Korea, they also have developed a hybrid laser arc welding for various shipbuilding applications. So, talking about hybrid laser arc welding, many shipyards have been using hybrid laser arc welding since early 2000s and still using presently. But as we know, none of the Indian shipyards have actually been adopted hybrid laser arc welding in their production flow. The major reasons behind this are First, it is not easy to implement. You have to completely overhaul the entire production floor of the existing shipyards to make the process viable, to implement the process firstly, because it's a fully automated welding process. And second thing is that because of the lack of access of the technology, it's a technology that is not really developed in India. Very few institutions have been doing research. As we know, the WRI of BHEL Trichy, they had developed a small hybrid laser arc welding, but not really taken off. Some developments are happening at NMRL of DRDO. But apart from some institutions, hybrid laser arc welding technology has not been really developed in India. And that makes the technology very costly. Only very few European companies hold the technology with them, and the charge they give to implement the technology is very high. But the main advantage of this process is that for the materials which will be used in the future, and still we are using like high strength, low thickness materials. If we keep on using the conventional arc welding processes, the amount of heat input will still be more. You will spend a lot of time addressing the distortions, addressing the heat induced defects, and will eventually make your production less efficient. So it's high time that the Indian industries, not only shipyards, many heavy engineering industries should also adopt this hybrid laser arc welding, and it's high time that we develop this technology ourselves. In the meantime, from 2000 to the present day, the laser technology has also evolved considerably. During the initial stages of implementing hybrid laser arc welding in the European shipyards, they were depending on conventional CO2 lasers. Now there are very advanced laser technology available within India. We have indigenously developed high quality lasers. Fiber lasers are available, which makes it very flexible, as well as gives a better energy output. So at present, India is equipped with all the technologies. The only thing is that we have to find the right partners. We have to find the right mix and generate the demand for this process, so that industries or research institutions will feel motivated to develop this technology in-house. And other industry, which our session chair is also an expert on, is friction stir welding. Friction stir welding has been there in various shipyards for a very long period of time, right from early 2000s till present day. It's a preferred method of welding aluminum, and the demand for lightweight ships and lightweight passenger ferries are increasing day by day. And still almost 100% of our Indian industries are depending on conventional arc welding to address the welding of aluminum. And aluminum, it's the thermal expansion is very high, the distortion produced is very high. So as long as we depend on conventional arc welding to address the joining of aluminum, we end up in doing a lot of reworks. We end up in spending a lot of time addressing the distortions. So for people who are not that familiar with friction stir welding, it's basically a welding process which carries out the welding without taking the material to the melting point. It's a solid state welding process. It primarily has a rotating tool which actually churns the joints or both the plates and causes a thermomechanical zone, and results in bonding the both plates. The strength of the bond that is formed is superior to that of the parent metal. And since there is very minimal heat cost, the distortion caused due to friction stir welding is almost zero. And almost 40% of our time and cost is saved due to this friction stir welding. There are technologies available in various countries like Australia, where there are portable friction stir welding machines, so which can be taken to the site and then carry out friction stir welding. Here there is no filler material, no shielding gas is required. So the overall the cost of raw material is also reduced, and since there is no arc production, the overall power requirement is also minimal for friction stir welding. And for both hybrid laser arc welding and friction stir welding, the processes are approved by classification societies like ABS, DNV, LR, BV, IMO. And it is also here we need to bring our attention of our own classification societies like Indian Register of Shipping. They should actually bring down guidelines for accepting hybrid laser arc welding, for accepting friction stir welding in the production flow. And even for hybrid laser arc welding, the 100% penetration is possible from a single side for both butt welding and fillet welding. So it is not a very common thing to see 100% penetration for fillet welding happening from a single side, which is possible for butt welding, for the hybrid laser arc welding. So these two methods, these two welding techniques, at least these two welding techniques, we have to develop the technology indigenously. Friction stir welding, there are a lot of research and development happening in various institutions like IIT Guwahati, in NIT Trichy also a lot of developments are happening in friction stir welding. But it is high time that the technology is actually used on the production flow. It is high time that it is moved out from the prototype stage, and standards are brought to accept the technology in industry. So it is actually a matter of national security that we have to develop the self-sufficiency in manufacturing. We have to reduce our dependency on import. Once we hold the technology with us, only then we will have the liberty to customize it based on our own requirements. So we have to develop the cutting-edge technology to suit our own requirements. The stakeholder Navy can also take the leadership role, being the primary customer for the Indian shipyards. They can also bring in their own guidelines, accepting hybrid laser arc welding or friction stir welding, or for that matter, any new welding processes which can drastically improve the productivity, and the benefit will eventually go to the user, that is Indian Navy. Shipyards should also open up their R&D and invest their R&D on improving the existing welding processes, as well as adopting new welding technologies. The technologies being developed in DRDO should be utilized by the Indian industries. We should also loop in private parties, laser manufacturers, and classification society and academia also, to establish the guidelines, so that there is a rule or a regulation for implementing the technology. And with this, I conclude my talk, and thank you for giving me an opportunity. Thank you.
Thank you, Dr. Krishna Prasad. Really, Your talk is so insightful and so knowledge-sharing talk. Really, these types of problem we are facing in actual field itself, whatever the things you are telling. Because so many research work is going on in India, you can't imagine. But what happens once we approach this thing to implement in any industry, they initially show a lot of interest, but what happens after a few days, after some time, generally they return back to their old technology again. What I'm telling, understand. To implementing a new technology like this, whatever the things you are discussing, is really a very means. I don't know why these types of what it's called negativity in this, especially in India and especially in Indian industries field. Because whatever the topics you told, these types of what it's called insightful information, actually we should what is called you can say spread out throughout the entire country, not only in country, throughout the stakeholder or industry. They, and we should approach them that okay, these types of thing is going on such a huge way throughout the entire world. What I'm telling, understand. These types of thing, these types of information is required to circulate the industry also. This is a right platform. What I am telling, understand. That means that INA. By this itself, at least we can what it's called circulate this information to great what is called investor, very huge what it's called applicables, what it's called shipbuilding industry, where these types of technology is very much essential. Now, I would like to request, Dr. VVS want to tell something. He raised his hand.
Perhaps a few comments before the other audience can join and they can put their questions in Q&A. So since nobody has put, I just thought I'll just start the discussion. Basically, perhaps I would just like Dr. Krishna Prasad's comments. You rightly brought out that changing an existing shipyard's technology could probably be having a huge capex as well as opex investments, because the shipyards are already used to a certain thing and the change is going to, not only they have to remove the existing equipment, but add. So there is going to be a capex and opex cost associated with that, which is a huge learning process, including replacement of the machines probably, not only just the consumables, but also the machines. And you also highlighted that Mitsubishi's experience. I just saw a brief comment that high costs somewhere when you showed about the Mitsubishi this thing. Considering that, my first question is, do you see that any greenfield small specialized shipyards, can they probably stand who was primarily shipbuilding is probably less than 6 mm plates because they're constructing less than 50 meters vessels? Do you think this technology can be directly introduced to small greenfield shipyards which are focusing on probably intern vessels because they are essentially thin plates there and distortions of this thing are anyway very huge? That is my first question. Second question is, once we change these technologies, there will also be significant requirement for training the skilled persons. And even now, skilled persons beyond 3G or 4G positions are very, very few, and we customize and train them as and when required. So do you see a significant investment which will be required for training the skilled persons to handle these new technologies? Just to start the discussion, these are my two these things. Perhaps Dr. Prasad can probably comment on that.
Firstly, thank you, Session Chair, for the encouraging words, and thank you, Haridwar sir, for initiating the question answer session. Firstly, sir, to answer your question, especially the first part where you asked whether it's a viable option for small shipbuilding firms to adopt this technology. So, as you told, most of these small shipbuilding firms use low thickness materials for their ship construction. The question comes to the affordability. So as long as the technology is affordable, it can be implemented in any shipyards. At present, it is not an affordable option because we do not have the technology. We need to depend on foreign technology to get this done implemented in our production flow. At present, sir, this is not a viable option for small shipbuilding industry, purely based on the affordability and the access of the technology, the lack of access of this technology in India. And answering your second question, sir, this process, I'm talking about the hybrid laser arc welding. If you take friction stir welding, also we need to develop this technology, and it can be easily scaled and easily adopted. We have the technology in India. It is there with academic institutions. It is there with certain R&D organizations. The only thing is that we have to scale it to adopt it. So if we can consider the first question as two parts. For hybrid laser arc welding, presently it's not a viable option, but for friction stir welding, I believe it is a viable option. The only thing is that you have to make the technology a little more matured so that it can be implemented. It's not a very expensive technology. The technology is basically with the tool design, which our our academic institutions have already done it. I don't know about other institutions. Anyway, IIT Guwahati and NIT Trichy have got the technology with them. It can be easily adopted. And talking about the skill requirement, here too we can divide it into friction stir welding and hybrid laser arc welding. For hybrid laser arc welding, it's a fully automated welding process because the laser power is very high. It's a class 4 type laser where you cannot do with any manual method. So it's a fully automated welding process. So once you, like any manufacturing process that can be automated, the manpower requirement is less. The only thing is that the person shall be educated to operate the machine. So there is not a huge skill addition that is required. The same case with friction stir welding also. It's even I or you can do friction stir welding if you learn to switch on and switch off the machine, and that is also an automated process. So the skill gap is not a big question, sir. The only question is the availability of the technology in-house.
So the session chair, just bring to attention of the session chair that there are a few questions in the chat box, not the Q&A box.
Yeah. Yes. I have seen box. Actually. Yeah. Yes, I have seen. So
we can invite them to the panel. Sir. With your permission, we can invite them to the panel. They can ask the question verbally.
Let's see. I am just seeing this thing. Yeah. That will be better. So one participant whose name is Ulhask UKE, actually his name. So he asked, friction stir welding is not a new technology. So you can add it if you want.
Sir, Kalgatki sir, you can just offer your comments.
Ulhas.
Yes, sir.
Actually, only the comment is like this. Yeah. The comment is that he asked that friction stir welding is not a new technology.
So Kalgatki sir, perhaps you can. I'm just inviting Kalgatki sir. Yeah. He's yes. Very senior retired surveyor from Indian Institute of Shipping, sir. Please, sir, your comments. We have just added you to the panel.
Yeah.
Kalgatki sir.
Yes. Definitely, you agree. Yeah. That will be better.
Kalgatki sir, your comments, sir. We have just read you and added you to the panel, sir. I think he is not audible. I see another question from Mr. Krishna Varia.
Yes. Yeah. Can I read this question? Can you please tell us the main impedance in indigenization of welding process? Is it technical or financial? Can production of welding equipment in India be economical considering rather a small number of customers? That's a very important question. Actually, Dr. Krishna Prasad, if he can elaborate this question, that will be very good. So I would request Dr. Krishna Prasad kindly incite some lights for his queries actually.
Thank you. And here too, sir, I would like to answer it from a hybrid laser arc welding perspective and friction stir welding perspective. The main impediment in indigenizing the welding process for hybrid laser arc welding is the technology. Once we were confident with the technology, only we will be able to find the cost part. So as far as we know from Cochin Shipyard, The technology itself is not available in India as on date. So only then the cost part will actually come. But for friction stir welding, both the technology is available. It can be easily implemented. The only thing is that the willpower of any of the industry to adopt it in the first time. One thing is that we are not very sure that the classification societies or the Indian Register of Shipping, they have guidelines on friction stir welding acceptance criteria. So if that is also there, then it's just a question of adopting the technology to the production. For friction stir welding, it's not a new process. I have not told it is a new process. The process has been there for a very long period of time, but none of the Indian shipyards have actually taken benefit of that process, and it's high time that we use it. For friction stir welding, it's just a matter of decision making, I would say personally. There is no technological challenge or no financial challenge.
Yeah, but sir, you have a comment, sir. You can perhaps come in first, sir.
Can I ask you for a clarification?
Yes, sir, you are welcome, sir.
Availability of technology. What exactly you mean by that? Availability of technology. This has been perfected and this is in process, is being used for years in other countries. And is it an economical problem, like financial constraint that is preventing you from getting the technology? Or training of personnel? What exactly is the difficulty?
As you rightly told, sir, and I have mentioned in my presentation also, hybrid laser arc welding has been in use in many shipyards globally. What I meant to say was that the indigenization of the technology has not been done, due to which we need to depend on the foreign technology provider, due to which the cost is very high. The cost of implementing hybrid laser, a fully automated hybrid laser arc welding production line, is very high. I meant to say that the cost is high because we are depending on the foreign technology. Only that. What I meant that the technology is not available is the technology is not available indigenously. So we have to depend the entire hybrid laser arc welding technology from the foreign suppliers.
No. When you mean the technology, is it the equipment or the training or consumables or what exactly?
Okay, so I will elaborate on that. Hybrid laser arc welding is a combination of laser welding, which is developed, it's a completely developed process. The technology is there. It's a combination of laser plus arc welding. That technology is also there. When you use hybrid laser arc welding is not a, what you call, a commercially off-the-shelf product that we can purchase. It is actually developed for customer needs, because the way that is combined, the way that is there is a hybrid laser gun which actually houses the what you call, the laser beams torch and the conventional arc welding torch. If you consider a normal welding process, say for example conventional arc welding, you have a fixed set of parameters that is going to influence the welding parameter. Similarly, when we are taking hybrid laser arc welding, we have two processes, and those parameters of two processes individually will affect the welding quality, as well as there are combination parameters like relative position between the laser and the torch, the relative angle between the laser and the torch, which is leading, which is trailing. Actually 3 times more parameters are going to influence the weld quality of hybrid laser arc welding. So as I told before, hybrid laser arc welding is not a ready to use or commercially off the shelf item which can be purchased and put it into use. It is actually a process that is customized for the applicator. Say for example, I am going to use it for panel welding. The panel welding is for plate 4 mm to 8 mm. I need to select a particular range of laser power. I need to select a particular conventional arc welding, say for example 400 amps of 400 ampere GMAW welding machine. In addition to that, other parameters will also be taken into consideration. What is the stiffness spacing? because only then the stiffness spacing, say for example, it is 300 mm or 500 mm, the available gap between the stiffness, that 500 mm, we have to make the hybrid laser arc gun so that the automated process is accessible within the gap. So it's a process that is purely customized based on the customers or based on the applicator's requirement. For that customization, you have to have the knowledge on how the parameters, the combined parameters will influence the welding. So unless and until we do not hold the knowledge with us, we need to depend on the foreign supplier. The foreign supplier who has the technology will analyze our own requirement, will make a customized gun, or will customize the process based on our requirement, which actually shoots up the cost. I hope I answered your questions. I'm ready to.
I got it. But that brings me to the next question. Now, considering the volume of work being done in Indian shipyards, do you think it is really makes a difference, or a substantial difference by adopting these latest technologies by paying so much money? Can you make it cost effective?
Sir,
Absolutely.
actually, I am to tell something about your queries, actually, sir. What happens here, generally, you are telling laser welding process. Laser welding process definitely is a very high cost, what it's called, a machine. You can imagine for a 1 kilowatt or 2 kilowatt, what it's called CO2 laser, this cost is around 1 crore rupees, sir. He has shown this what is called the laser we have required for this welding process. It is also more powerful than even 2 kilowatt. I have seen. So it cost can be little bit more higher side. Definitely, it is a very costly process, which is very difficult to implement in actual industrial scenario. But here, this laser, instead of laser, he is just showing a case study, sir. So what we can do, instead, laser is acting as a preheating mechanism that you can see. It is just preheating the things. And what happens after that, once you do the welding, then what happens from MIG welding torch, the heat requirement will be less. So instead of considering this laser as a preheater, why not think some different way? He is showing like hybridizing the process. Like instead of laser, if we put there a plasma arc, what happens? That also can be helpful. But we need to think about these types of ways. But again, when we go for hybridizing the techniques and trying to implement the techniques in industry, then we face problem. That things only Dr. Krishna Prasad is telling what I feel, sir. So hybridizing generally not only by laser, he is just showing just a case study. We can do hybridizing by a TIG arc itself, by some other plasma arc itself, which is also very high intensity arc types of thing. By this also we can preheat the things and we can increase the penetration and all the things. What actually is doing by laser? What I feel, Dr. Krishna Prasad, is it correct?
So I'm afraid there is a small clarification. I would like to clarify that once more. Hybrid laser arc welding, as you told, laser is not doing the preheating. Laser is contributing to 70% or more than 70% of the heat. So there are hybrid processes like what you told, combination of plasma and make combination of even various other conventional arc welding processes. The utility of hybrid laser arc welding is basically due to the low heat input that is going to the material, because the primary heat source is the laser. So there is no thing of taking the laser out of equations in hybrid laser arc welding. It is hybrid laser arc welding. So my intention is actually to
both the things.
Yeah, my intention, sir, is to introduce this technology to the audience. It's not a hybrid process. There are hybrid processes. There are particular use cases of hybrid processes, but I particularly meant hybrid laser arc welding. You know, the laser cost is high, but I'm answering to Krishna Kuti sir's question also, along with your question. Yes, the investment cost of hybrid laser arc welding is high, maybe 3 to 5 times more than that of conventional arc welding process, automating a conventional arc process. But the productivity is very, very high. to the tune of 3 to 5 times, because the welding speed, if you just take thumb rule, so if you just take thumb rule, conventional arc welding process are the process which we are using in 100% in the Indian industry. You know what is the speed of welding for conventional arc welding? Varies from thickness to thickness, 0.3 to 0.6 meter per minute. And here in hybrid laser arc welding, we are talking about minimum 1.5 meter per minute, and a speed of up to 2.5 meter per second is being there in shipyards, which is more than, you see, 1.3 or see 0.6 to 1.5 is more than double. And if you are able to attain 2 meter or 2.5, it is 4 times the productivity. So that return of investment will be there within maybe 2 to 3 years. And that's what we the European shipyards have done. They have implemented hybrid laser arc welding initially to address thicknesses from 4 to 8, and they have got the success. And now they are keep on investing on it. Why? Because the productivity benefits are very high. It's not only because purely because of the speed. In conventional arc welding, when you are using for low thickness materials and medium thickness material, you have plenty of heat input that is going, and 60%. And we have done a study here in Cochin Shipyard. The rework time for the entire production time, the rework time contributes 65% of the production time. And you are adding on to the cost of the time is actually cost, and you are adding up the time for addressing the rework, for which case in hybrid laser arc welding you have minimal, because the heat input is very low. So considering, it's not a question of considering the initial investment cost, it's considering the return of investment. No, it will get break even within 2 to 3 years based on the productivity. You have to put the automated production flow, production process continuously in the production line. It's not a question of shift operation, like from morning 8 to 5, switch it on and switch it off. No automated production processes will reap in the benefits if you work it in a shift manner. It has to work round the clock. Only then you will get the maximum productivity. Say, for example, if you are able to put an input plate and get the output in 8 hours, if the production floor is continuously running, that second plate will come in maybe 3 hours, because it's a production line. No, it's a sequence of production that's happening. But if you switch it off and then switch it on, every panel will be completed only with 8 hours. Whereas if the continuous production, if the automated production line is put in use continuously, even though the first plate comes after 7 to 8 hours, every 2 hours you will get the production completed panel. So it is how you have to see. It's not the investment cost. It's actually the productivity benefits out of this process. That's the main driving attraction.
Excuse me, sir. I agree that the productivity can be increased considerably. But my question is that by increasing the productivity in just one sector of the thing, will it really matter that much? Because I know, even considering the building process is the most important or most time consuming or major percentage of the work. But even then, after you complete the welding or fabricate the hull, can you keep pace with the other departments like outfitting and machinery erection and things like that? Otherwise, what is the point in quickly welding a hull and then keeping it there? I've seen in the yards where I've worked abroad, they have they make the hull in very fast, but then the blocks are there waiting at the yard for erection and joining, and then waiting for machinery and even other things. So just improving only one aspect of the building, will it really matter that much? That is my doubt.
So that's a question that has to be answered from a production planning perspective. So from a pure production perspective, what I have told is right, but considering an overall productivity improvement, as you told, there are a lot of factors that contributes to completion of a shipbuilding project. It not only starts with, starts or ends with ship panel construction. There are, you see, time taken not only for outfitting work also, but for the design work as well. So it's a combination of procurement, it's a combination of design, it's a combination of panel fabrication, outfitting, commissioning. So you have to bring in changes everywhere. Only then, as you told, there will be a benefit out of it. But still, we have to start somewhere, right?
Just this thing, Mr. Kalgatki wanted to add something, sir. We've added you in the panel, sir. You wanted to join verbally and comment, sir? Kalgatki, sir? He raised his hand also in between. He had also raised his hand in between, so I'm just wondering whether he wants to offer further comments. Perhaps he joined later, sir. Perhaps, sorry, one more big thing which came about. Dr. Krishna, you were also commenting on class requirements actually, and you were told that at least international class tools are available for friction stir welding. And considering the use in the shipyards, I think for hybrid laser also rules should be available.
For both hybrid laser arc welding and friction stir welding, it is available.
Yeah, because shipbuilding process as such is heavily dependent on the corresponding availability of the class tools at a very practical level. Do you think that part also has to be addressed significantly in indigenous, or we can rely on foreign class tools? Because a lot of specialized tools, we are relying on foreign class tools. IRS being a member of IACS, it can also still be done. But do you think significant investment is required in developing of the class tools also in this regard? Or we can start with the foreign class tools in this particular case?
So as you rightly told, we can start with the foreign class tools, sir. For example, for hybrid laser arc welding, DNV has rules, BVLR has rules, Class NK has rules, Korean Register has rules. So, and even AWS, American Welding Society, they also have codes for hybrid laser arc welding, D7.6. So you have all the data with us. There is no requirement for us waiting for IRS to bring in new rules. And for friction stir welding also, ABS, DNV, all the players have classification societies have rules. So it's a question of just adopting, sir. For industries, we can actually adopt those standards, and then IRS can subsequently bring in their guidelines. The most important aspect of hybrid laser arc welding is not really the code. It is actually the question of safety standards. Because in India, for adopting this high power laser arc laser in production flow, we have also inquired. We do not have a regulation for this implementing high power lasers. So in for the safety aspect, definitely it varies from country to country. The European standards would be very, very stringent. It's not that we normally maintain a less stringent safety standard, but the safety aspect and safety guidelines should be considered as a priority rather than the manufacturing guidelines for implementing hybrid laser arc welding.
Yeah, Kalgatki, sir, please, sir. Please add your
Can I come in?
Yeah, please, sir.
Manu
Please.
Kurla here.
Yes.
Yeah. Wonderful and very good
evening,
discussion is happening. It's very good. I just would like to ask one question. Do we have, Cochin Shipyard has an intention to adopt or work in this area? This is to Krishna Prasad. Cochin Shipyard is a leading shipyard. We are hoping that you will be taking the lead to make India a world shipbuilding leader. And what is your intent and what is your appreciation about implementing it some point in time?
So definitely, we will be taking a lead role in implementing this technology. Maybe in a couple of months' time, hopefully, sir, we will be implementing. We are seriously thinking of pursuing it.
It's nice to hear. So you have said that there are 4 major aspects in this. That is application of laser and the safety associated with application of laser, in the workplace. and the rules of the road has to be set in, and we should have necessary funding for taking up this. We should have necessary workload for taking up this. And the technology per se, I understand that, if you have a laser and the physical systems in place, then also you should have the associated software and robotics, because every time you cannot decide what should be the gap, what should be the laser strength, what should be the feed in. These aspects may have to be, you have to sort of AI and all the modern techniques may have to be brought in. So this is something which is involving all the modern technologies, modern development that has happened. It is amalgamation of all these things, and we should have a will to go aboard. I'm happy that Cochin Shipyard is looking into this, and you are trying to implement a system which is going to really, improve our production capability. Uh, I'm sure this may not be an end to it. It may be a starting point where he has brought in the new philosophy, and we should have wider discussion on this. Now that Professor Pankaj Biswas is already there from IIT Guwahati, and I remember Krishna Prasad mentioning IIT Guwahati has started some research in this area. I know about in India, laser sources and research on laser is also progressing well. And at the amalgamation, this is a product that can come out and which can improve the productivity. Anyway, the procedures for progression, procedures for development and implementation, this is everybody's, involvement may be required. All the stakeholders have to be identified. Probably Cochin Shipyard can initiate this process of bringing together all the stakeholders who may be interested in application of such technology, and that may make the economics better. That may work out, the cost of development down. This I really appreciate for bringing, this particular topic for today's discussion. It is basically the dream that India has to be a technology leader, and all the infrastructure that is required, all the upskilling that is required. This is a starting point. It is very good that we have had this wonderful discussion. Anyway, that's my comment. Anything, anybody would like to add, please add. Others' comments also are requested. Bharadwaj sir.
I was seeing Kalgatti sir raising his hand several times, but somehow he is not able to join. Considering his seniority, I thought his experience and comments would be very useful. Are we audible, Kalgatti sir? We're not able to get him. So now, again, I'll leave it to the session chair, so Professor Biswas.
Okay, thank you. If any participant have any other question, they can ask. Frankly speaking, actually, this is really a very interesting topics which Dr. Krishna Prasad presented. And these types of initiation is required in India at least. Though both the technologies are available, but I think again, what happens, instead of procuring the means setup from foreign country, if we can do some research, combine this two technology together, I think that is also a good initiation. What I feel, Dr. Krishna Prasad.
Sir, exactly. So only if we have the technology with us, we will have the power to customize it based on our requirements. Because all the industries, even shipyards, we have our own production flows. So if we have to use it in synergy with our production flow, it has to undergo a lot of customization to suit our requirements. So if we only have the technology with us, we will have the power to customize it based on our requirements. Otherwise, sir, we will be solely depending on a solution which a foreign player will provide us, for which we have to really overhaul our entire production flow, which may or may not be as per our requirement. And not only implementing the life cycle support, for which we may have to depend on the foreign players. It's a production, it's a key vein, or what do you call, say, key area, which will impact our production. So any downtime or any defect that happens, it has to be addressed very quickly, which can only happen if we have the technology readily with us. Otherwise, it will seriously impact our production flow. So if you take the examples of any shipyard, say for example, Naval, they develop the technology themselves with a support of a university. And certain industries, certain shipyards, they have the financial power to bring in PEMAMEC or very big players to implement it. So considering us as a developing country, and we are not as huge shipyards or industry, a sustainable method is to have the technology homegrown and implement it and in our production flow. Only then, sir, we will have the power to use it maximum and address the customization requirements.
So is it not possible to start actually before procuring the machine? Is it not possible to start these techniques or this research in collaboration with you and IIT Guwahati? Because we have all the facilities, frankly speaking. We have, but what happens? That hybrid techniques together, a machine we don't have, but we have laser, we have MIG, MAG. What I'm telling, understand? Plasma every year. This well-equipped setup is with us. So because you are telling this machine also is applicable for a very thin section, correct? I have because this is 4 to 8 mm thick section.
Actually, it's a very scalable welding process. The thickness depends directly on the power of the laser. So for Fincantry, they have developed it up to 20 mm. That's a directly proportional to the laser power that you use. The thumb rule is for 1 kilowatt, 1 mm. So for 20 mm, 20 kilowatt. For 10 mm, yeah. 10 kilowatt. So the thumb rule is like that. So it's a scalable thing. But for higher thickness, our conventional welding process is good enough, because for higher welding, higher thicknesses, conventional welding processes will not cause that much distortion and all. So the justification for hybrid laser arc welding may not be very attractive for higher thickness, because the same technology what we normally have can be just a matter of automating it. We need not manually do it, just a matter of automating the conventional welding process. That's how the Chinese shipbuilding and the Korean shipbuilders have actually used, because bulk of their shipbuilding requirements are bigger ships. For bigger ships, the thickness is very high. So they just need to automate their conventional welding process, bring in tandem welding processes, and bring in hybrid conventional welding processes. So it's just a matter of automating the conventional welding processes to bring welding efficiency for higher thicknesses. The use case for hybrid laser arc welding is low to medium thickness. Only then you can actually justify the expense and investment.
Very good. Very good. Any participant and any other questions? I think no further queries are there, what I feel. So, with the permission of, Dr. VVS.
So no, just commenting, sir. No further questions.
No further queries are there.
Yeah.
So I think by this, actually, we are very close to the end of this session. And really, it's a very interesting topics. And in my opinion, actually, if Dr. Krishna Prasad won, we can both together have a, what it's called, collaborative work if you want, because we have all the facilities. Before procuring that setup, we can have the different what is called research in this what is called, and developing a new techniques with the help of this MIG and what is called laser source. That is a combination of these two technology. If we can develop further some low cost portable one, because laser, once its power will be very little bit higher side, it will be very heavier. It will not be a portable things. Shifting from one place to another place also will be very difficult task. What I'm telling, understand, correct, Krishna Prasad? So initially, if we can do some what is called initial research on that before procuring the things, I think that also can be helpful. Definitely, we can start with existing one. I'm just telling you, before procuring the things, if we can collaboratively work together some initial work, that can be also that may be also helpful to you to check the what is called incitement of this setup. What I'm telling, understand?
Noted,
Dr.
sir.
Krishna
Noted.
Prasad, if you,
Sir,
okay.
noted, sir. Noted.
Okay, you can definitely procure it. You know that in INIT Tiruchirappalli also 2 of my students are there who are working in this field also. What I am telling, understand? And I have also some knowledge on laser welding, because I have guided 2 PhD scholars in laser welding also. What I am telling, understand? I mean, I know what is the pros and cons of laser welding process. Okay, but definitely that's a very interesting techniques. But before going to procure this thing, if we can see actually what is the limitation, what is the again problem, or what is the advantage of these things, that definitely will be helpful to you. What I'm telling, understand, as well as at India also. What I'm telling, understand. Before procuring this thing, we should have some initial research on this. What I feel, in my opinion. So thank you. Actually, by this again, 2 participants raised their hand. But actually, I have an urgent meeting. Actually, I need to leave. Actually, Dr. VVS can chair this session in absence of me.
Okay. It's okay, sir. Perhaps
okay. Thank you.
Discussions will continue, but what I would
okay.
probably ask is they can always put their questions in the chat box or mail to us. We will connect Dr. Krishna Prasad and continue the discussion, because it's a very interesting topic.
I'm coming.
So
yes.
perhaps
perhaps
now
yes.
I'll just move on probably to the end of the talk. I'll receive comments from Dr. Kalgetki and Mr. Warrior by email, and then convey, and we can continue the discussion later also.
Yeah.
With that, sir, perhaps with your permission, I'll move to the vote of thanks. My first thanks is to Dr. Manukurla. He is the president of INA, and with him, all these activities are happening. Regular webinars are happening. And Professor Biswas, Pankaj, I just called him quite late, and then he readily agreed. And thanks, because thanks, and you just brought in your expertise and.
Actually, today full day we had BTP. We had full day BTP.
Yes,
I completed my BTP just afternoon 4 p.m. only.
Yes.
After that, actually, I prepared for this. Okay.
Yes.
Okay, fine.
And Dr. Krishna Prasad, I contacted him some time back. I knew him in a different role, but he readily told, and very lively and important topic, which is basically giving me a prescription of for future technology development. I would also separately discuss with Professor Biswas probably at a convenient time to take it forward in a certain way. And Mr. Krishnankutti and Mr. Kalgetki for their insightful comments and the lively discussion. And I would like to thank the background team in INA, Mr. Amir Ahmed, who is ensuring that this is seamlessly happening, and the participants who have joined and made this. Their presence is why we do this, and we also thank all the participants who are there, and the INA Executive Council team, which is the backbone for all these activities. I would also announce the lecture for the next month. It is on 24th of May, and we are having a lecture by one of the most senior practicing naval architects, Dr. M.K. Ghoshroy. So I would advertise to all the audience. He is talking on transitioning to FEA in ship structural design, and considering his experience probably from 60s to currently, we are going to have probably an outlook of how over 6 decades structural design has evolved, both in terms of technology up to the most modern technology. He has also very recently published a book on the same topic. So it is not just going to be history, but also going to be very contemporary. So I would invite all of us to join that lecture, which is going to happen on 24th of May. With this, I would like to thank all of you for joining and have a great evening this weekend.